So let's try and do a couple more while time permits. You're going to bend a piece of wire 12 meters long into two pieces. One's bent into a square, one's bent into a circle. So the total wire that you have to work with is 12 meters. Okay, so some goes to the circle, some goes to the square. I want to try and find, well, how should you cut things so that you get a minimum in one and a maximum in the other? Well, one thing's going to be nice and clear, though, for us is the interval. Now, as far as the rest of this is concerned, let's figure out, well, how much are we going to use for, let's start out with the circle. So there's our picture. Let's work with the function. You've got a total of 12 meters to work with, and I want to find the area, and I'm just going to write this in general terms to start with. And this is kind of something I would suggest that you emulate to an extent. We want two areas. I want the area of a circle plus the area of a square. How do you find the area of a circle? Somebody said it, pi r squared. How about the area of a square?
X squared.
All right, I'm going to use s, but yeah, x squared, that's fine. So length of the side squared. We're running into a familiar problem with these things, though, and that is I got two different variables. I've got to replace this. I've got to write it with one variable. So let's play around with that for the moment. We've got 12 units of wire. Okay. So 0 to 12. Now you can cut this any way you want. But wherever you cut it, I'll call that length x. What's the rest of this going to be? How much, if I cut out x here, if I cut out 8 units here, how much is left here? 4. If I cut out x units, then how much is left here? 12 minus x. Now, let's use this to build our circle and this to build our square, just because this looks like a little bit messier, and I think I'd rather use it for the square. So that x is really going to represent our circumference, right? Okay. So we'll have to play around with that for a second. So let's see. Circumference. Now the cool thing is that you can differentiate this relationship with respect to r and remind yourself for the circumference. When you differentiate this, you get the circumference is 2 pi r. And for us, that's going to mean r is going to equal, r is going to equal x over 2 pi. What about the area of the square? Area of the square, area is going to equal the length of the side squared. But what's the length of the side going to be here?
It's going to be the absolute value of 12 minus x.
Well, we're not going to use, well, let's see. Remember that 12 minus x is going to have to wrap itself around this square. How many sides are there?
4.
So really, 4 times the length of the side is going to equal 12 minus x. So the length of the side is going to be 12 minus x over 4. Or if you want, you could write it as 3 minus x over 4. Either way. But with these changes, we can now substitute into this formula and get something that depends just on x. So that was our goal here, is to rewrite these so that it just depends on x. We solved for r in terms of x. We solved for s in terms of x. That was our goal, is to get a formula that just depended on that one variable. So let's see. Let's see. Call it a of x is going to be pi times x over 2 pi squared plus, which one do you want to use? I think using this one is going to be a little bit easier. 12 minus x over 4 squared. Let's clean these up a little bit, because at some point we're going to have to differentiate these things. That's going to be pi x squared over 4 pi squared plus, I'm going to have just a 16 in the denominator, and then, let's see, 12 minus x squared. I'm going to leave that squared like that in the numerator. I can get some more simplification if I cancel out one of these pi's. So I'll just write that as 1 over 4 pi times x squared plus 1 over 16 times 12 minus x squared. So finally, I wrote things that depend just on one variable. Now let's think about the interval. Are we okay with the function part? So there was a lot of work there to get that function. And that's not going to be atypical for these types of problems. Thumbs up on the function. Doing good there. Thank you. The interval is going to be nice and different on this one. What's the interval? 0 to 12. Brackets or parentheses?
Bracket on the right side, parenthesis on the left.
Actually, brackets for both. So if x is the material that you're using for the circle, and if x is 0, then you're putting all the material into your square. And then vice versa. If you put all the material into your circle, then 12. All right? Okay. So you're actually going to include the endpoints. If you looked at this on the graph, or you looked at it with the function, you kind of see that's really going on. So when the area is all, when you use all of this for the square, then you're going to get the area of that one, 12. So somewhere in between, we're going to have a minimum, but the maximum might actually be at one of the endpoints. So let's play around with that. That brings us to the last step here, which is the analysis part. So for the analysis part, we got a of x is 1 over 4 pi x squared plus 1 over 16, 12 minus x squared. You could, oops, sorry, I didn't realize it wasn't on the screen there. You could, if you wanted to, FOIL this out, etc. I think I'd rather not. Let's see how far we can get without doing that. A prime of x. Well, this is just a constant, so we'll differentiate the x squared. The 2 is going to come out in front. It'll cancel with one of the factors of 2 in the denominator, 1 over 2 pi times x plus 2 over 16. I know that's 1 over 8, but I'll just leave that there for the moment. Times this. Almost. What am I missing here? Derivative of the outside is 2 times this, times the derivative of the inside. The derivative of the inside is -1. So you got to be careful with that. Let's clean this up a little bit. 1 over 2 pi times x plus, well, -1 over 8 times 12 minus x. I suppose I still want to clean this up a little bit. Do I? Maybe. Maybe not. Let's see here. I want to know where that's equal to 0. So I think the easiest thing for me to do at this point would be to clear out the fractions by multiplying through by the lowest common denominator. What's the LCD going to be for me in this case? 8 pi. So multiply both sides by 8 pi. That'll distribute itself here and here. So that'll give me 4x minus pi times 12 minus x equals 0. So at least I got rid of my fractions now. 4x minus 12 pi plus x pi equals 0. Move the 12 pi to the other side. That's going to leave me with 4x plus x times pi. I'm going to factor out the x from the two terms that remain here. So it's going to be 4 plus pi times x, or x equals 12 pi over 4 plus pi. Okay. Now this is just a critical point. I don't know if it's a minimum or a maximum or what, but we only get one critical point. If we think back to our work with maximizing and minimizing functions on an interval, then you've got to test a critical point and what else? X, a of x. You've got to test the endpoints. So I got to plug in 0 and 12, and then in between here, I've got to plug in 12 pi over 4 plus pi. So you're going to get maximums or minimums at these points. Let's see what happens when I plug in these points into my function, and then I think that'll be it for today. All right. So a of 0 gives me about 11.46. Then at 12, something doesn't feel right about 12. This might not be the place to put in, let's see. No, a of 0, that can't be right. This isn't the right function. This is just something I used to draw this. I'm not sure that this is really the right thing. So we need to put a of 0 in here. That would give me 144 divided by 16. That's what, 9? Yeah, that'd be 9. So this would be a 9. At 12, you're putting all the area into the circle. So it'd be 144 divided by 4 is 36. 36 divided by pi. What's 36 divided by pi? Someone want to crank that out for me? 11.46. 11.46. You know what? I did have that point there. That was right. And last but not least, we need to evaluate this at 12 pi plus pi, or divided by 4 plus pi. Let's see, how am I going to do that? I think this one might have been right.
Yeah.
Because at 0, oh, these are just, I think they're just reversed from each other.
Yeah.
All right, but what does that leave me with for pi? Let's just take kind of a peek here. 4x. Yeah, it's a little off. It should be This should be 1 divided by 4 pi and then x squared. Okay. That matches things. That matches up things. So let's do a of 12 pi divided by, where is it? 4 plus pi. There you go. 8.289. It's approximately 8.829. Nice. Now, if you had to, you can plug this into your calculator to make it do those kind of calculations. So, not too bad. Fortunately, this is a closed interval. I'm not going to worry about anything else because there's no other critical points and we tested both endpoints. So we've got a minimum at this value of pi, and you've got a maximum, excuse me, minimum here when you're kind of splitting things up between the circle and the square, and the maximum is if you put all that to the circle. All right, that's good enough for today. I wanted to get some more, but sorry. See